Hi guys, my name is Ivo and I'm from My Tested ASP.net. In this video I am going to do something a little bit different because usually all my previous videos had some sort of a lesson on topic which is kind of out of context. For example, we did some reflection lessons, we did some expression tree lessons, but all of them were not that practical during the video and during the lesson. Yeah, the features I explained are practical enough and you may find them useful in your application code, but most of the time I don't show a real life project which is used by lots of users. So I decided to show you how I implement a feature in one of my frameworks. That's My Tested ASP.NET Core MVC. And essentially that's a fluent testing library for the popular Microsoft framework, which allows you to write quite fun tests by using a Fluent API like this. You can say my controller instance with some user, calling that action should have valid model state and should have viewback and should return view with model, which passes and so on. So the library is quite powerful, but it's missing an essential feature for such a tool. And that feature is to have descriptive enough error messages. Some of the messages are completely fine, but the messages I'm going to solve now are kind of not okay. So just as a side note, before we start and before we dive into the code, I would like to say that I have not prepared for this video and I'm going to implement the feature live. So we may introduce a bug. We will fix it afterwards, of course. We're going to write some tests to validate whether the feature works. I'm going to think at some moments. I'm going to pause the video when I believe I'm going to waste too much time thinking. But keep in mind that it's not going to be a normal lesson, more like a live coding workshop on one of my projects. Let me give you a little bit of context, what I want to fix and what I want to solve in this video or video series if it becomes a little bit longer than expected, because the feature actually is not that easy and it involves algorithms and it involves recursion and it's kind of a deep feature. So what's the feature? In my unit tests, I allow my users, essentially the developers who use the library, to validate their results from their controllers, actions, view components, services, and so on in a very useful and easy to write manner. For example, if we have an action result which returns some kind of data like this one, some anonymous object, it doesn't need to be anonymous. It may be a normal response model or something like that. It may be a collection. It doesn't matter. So if our action returns some data, we want to validate whether the data is correct. So one of the ways to write such assertion with my tool is to say my controller instance calling the action should return OK, because the result here is OK result with data. And then I can say with model, specifying data, and provide a new model completely different from the returned here. And my framework will go property by property and will validate whether that model is exactly with the same values. And this algorithm is using recursion to traverse all the properties, and it considers a lot of stuff actually. We will see in a moment the algorithm itself. It considers a lot of stuff. For example, it considers whether you have a collection. It should traverse all the elements from that collection. It considers whether you have lots of nested objects. If you have 9 nested objects one into another, my algorithm should work. And some other considerations, but essentially it's an algorithm to compare two objects, generic objects. It doesn't matter whether the object is a cat or a dog or a rabbit or something else. It compares object to another object by traversing all of the properties, all of the collections, all of the nested properties, and so on. Essentially, it's a deeply equal algorithm. There are a lot of algorithms like that, but I decided to implement my own one. We will see it in a minute, because I needed to make sure that every specific scenario for the tests is covered. So I implemented one. This is already done. We're going to take a look at it to see how it works and what it considers. But the problem here, let me just run the test. If I run the test, this is fine because both the response model here and this one here are deeply equal, and that's completely fine. So essentially, I would like my library to be able to find differences and report these differences to the user. So if, for example, we have a wrong value, we will receive an error message. So my algorithm works, but the problem is that the error message is quite generic. When calling that action in that controller, we expect the response model. This is the type of the response model. It's a bit of ugly, but we're using anonymous objects after all, to be the given model. So the user expected the result to be this, but actually it was a different one. So from this error message, I know that something is not quite right in this object. So it's different from the result here, but I'm not sure what's the difference. If I'm the developer right now using the tool, I will need to check each property one by one and to see whether there is something different. And if the model is huge, for example, it has 20 properties with 10 nested objects and so on, it will be quite annoying for the developer to find that this is the mistake here. So essentially, I want to improve my algorithm by implementing better error messages, and report them to the user. And early today, I started developing the feature, but then I thought, well, this can be quite useful for the people on my channel, because I will explain the algorithm itself and I'm going to code some stuff in it, and I will add new features, so you will see how I think when I have to implement such a feature, which is not that easy actually, and it's not that difficult too, but it's kind of in the middle ground, so it may be useful for you. Again, keep in mind that I'm going to live code this one. I have my solution in my head, but I'm not sure whether it will work. So we're going to implement it right now. Okay, so how I'm doing this specific equality comparison is I have a static reflection class, which does quite a lot of reflection helping with my tools and my assertions. So essentially here I have two methods which are deeply equal and are not deeply equal. Both of them expect two objects. As you can see, the objects are quite generic. You can pass whatever you like. And these two methods will compare the objects property by property, nested object by nested object, collection by collection, and so on. but they return true or false. They don't return where the difference occurs, and they don't report what's the difference. So essentially, it's useful, but it can be annoying if you want to find the difference in your object. So I want to improve that in my next version of the tool. I have a couple of problems, and these problems are that these methods are deeply equal is used quite a lot of times in these two. These are used on a lot of classes, and most of the time the classes are used the methods are used like this. If these objects are deeply equal, then throw some error, and we can see that the error is too generic. In fact it was different. It's too generic. So what I would like to do is to improve the algorithm without breaking all these functionalities. So I would like to have two overloads, one which returns true or false, and another one which returns the actual the actual report. And just to make sure that the algorithms work, I have a lot of unit tests for these algorithms, for primitive types, for enumerations, for some objects, casted objects, not casted objects, normal anonymous types, normal objects, comparable models, which implement iComparable, generic comparable models, and nested models, collections, and so on. So if we take a look, we have quite a lot of unit tests to validate our logic, which is kind of cool because I am going to confidently change the algorithm, and I'm going to be sure that after the changes are done, the algorithm still works. And I want to keep that overload which returns true or false, just to not rewrite all these unit tests to validate the new format, which will return an object instead of true or false. Good. So how does the algorithm works? Essentially, the algorithm starts from here. It's a recursion which receives two objects and receives something which I believe a lot of people will not know. That's conditional weak table is from the C# language itself, and it allows me to validate whether one object is whether I have an object or whether I have visited an object or not. So essentially this conditional weak table allows me to add an object to it, and later I can check whether that object with that memory reference has been visited already. The idea is, if I have reference loops in the response models, I want to be sure to not check them more than once. So if I have objects which are repeating themselves in the tests here, I want to make sure that I'm not validating the same objects again. And also, if I have reference loops, this recursion will not stop. So essentially I need some kind of method to check that. Fortunately for me, the .NET framework already provides a way to check that. It's very easy. If I add an element to that conditional weak table, and if I try to get it afterwards, if I receive true, then I already visited that object. It's kind of easy. It checks this table checks only the memory reference, which is essentially what I want to check. Okay, so the conditional weak table aside, I have an object expected and object actual. This is the expected result from the test, this one, and the actual is essentially the actual model returned from the action. Cool. So first I do some checks which show me if both objects are no, I return true. That's completely fine. If one of them is no and the other is not, then it should be false because the objects are not the same. Then I get the types and I check whether it's not a value type and validate whether I have already reached that type previously in my recursion. I'm not checking primitive types because they don't have the same reference. If you have, for example, two zeros, two variables holding two zeros, you will not have the same reference, so I don't need to do that check for value types. And also strings are an exception here, and I cover strings later in the algorithm. Okay, and if I haven't met that object already, then I continue. And first thing I need to check is whether one of these is type of object. And if one of these is object and the other is not an object, directly the type object, then I return false, because if I have a cat and if I have an object, I cannot, both of them are different. If I have two objects, then that's fine. The object is a special case which I need to cover, because when I use the reflection later in the algorithm, it again gives me some errors, so I needed to cover the object case by itself. Then I check if the expected value is actually an enumerable and it's not a string, so it's a collection, for example an array, or for example some sort of list, hash set. I then check whether a collection is deeply equal by providing expected, actual, processed elements, and so on. So let's check that method and see. I get the expected as enumerable, and if the actual is not an enumerable, I return false, because if I have to compare a collection with a cat, they are not the same. Then I get both values casted as object, and I get a new collection from these, and I compare the counts. If one collection has five elements and the other has 6, then these collections are different, so I again return false. Then what I do, I try to find at least one object which is not deeply equal from both collections. So I get from the expected values, each object in the expected values, I compare it to the other collection, and if the collection is not equal, I return false. This method here is essentially the same one we started from, because we have our recursion. We reach a collection, the collection has objects, and one of these objects needs to be compared. So I return the call back to this deeply equal method. So again, I check these objects, and next thing I need to do is I need to validate whether the object is anonymous, because anonymous types from different assemblies, even if they have the same signature and the same properties, they're considered different types. So if my action here is from the controller's assembly, from the web application, and I would try to compare it to this one, which is actually an object from the tests assembly, these two are not the same types. So I need to check whether I have an anonymous type, and if I have an anonymous type, I need to check whether the other one is anonymous. So the anonymous type just checks with some mumbo-jumbo logic, but it works, whether the type is generated from the compiler, so it's anonymous or not. Cool, so if both of these are either anonymous types or are either non-anonymous types, I continue. Then, what I need to do, I need to check whether the expected type is assignable from the actual type and whether the actual type is assignable from the expected type. What I'm trying to accomplish here is I'm trying to, if for example, the developer returns an list but decides to test here with some sort of array or another collection. So essentially, if both collections are different, then I try to I can compare them. So this is why I'm checking whether, if both types are different, for example, if I have a list of int and I collection of int, these types are different. But if one of them is assignable from the other, for example, the list of int is essentially an enumerable of int, I would like to check them because both collections may be the same, may have the same values. So I need to check that. Let me find a unit test for that. Here it is. I have a list of nested models, these two, and array of nested models, these two, which are the same, and I try to validate whether they're deeply equal, like this. I have a list of int from 1 to 3 and an array of ints with 1 to 3. Essentially, these collections have the same value, so a search should be true here. And this check validates that, and also validates whether I'm returning, for example, an animal from, for example, a cat. I'm returning a cat from the controller, but in my test I validated whether it's an animal. And if the animal has the same property values as the cat, it should be fine. So essentially this check does this. Validates different types which are assignable. Cool. If the type is primitive or it's an enumeration, I just call the toString method and return that result, because when the type is primitive, you can compare the string representations, and that will yield great results. Good. Then I try to, sorry about that, I try to check whether there's an explicitly overridden equals operator, and if there is one, I will invoke it. So if my user overrides the equals operator, I will use the equals operator to compare the two objects. So essentially, I'm finding whether this object has that method, and if it indeed has the equals method overridden, I just invoke it with the expected and the actual and return the true or false. Then, if both types are not equal, again, I try to find the equals method. And if I have an equals method which is declared in an expected type, then I will invoke it. Maybe here I would need to check that functionality, because maybe it's better to check whether the equals method is not declared on the base object type, but I will validate that. after the video. Good. So I will check the equals method too. Keep in mind that this is the equals operator. If you overwrite the equals operator, I will have that method here. And this is the equals method which you can overwrite in every object, which comes from the base object class. So these two essentially check for these equalities. Then I will validate whether comparables are deeply equal. Comparable is essentially, I will see whether the object I'm going to compare is I-comparable, and if it's I-comparable, then I compare it and return true if it's the same. So if the user uses I-comparable objects for some reason, I need to make sure that these I-comparable objects work correctly. Then, if it's not I-comparable directly, but if it's I-comparable generic, so if it's I-comparable from T, like this, if it's I-comparable from int, I need to check that too. So essentially this method needs to check both the I-comparable versions and the generic I-comparable versions. So the second one is checking whether the type has an I-comparable. And if it has such an interface, then I find the compare2 method and I invoke it. Unfortunately, without the generic type, I'm not able to invoke that method, so I use this string. Okay, great. And after I validate that the objects are I-comparable, then I validate whether its properties are deeply equal. Its properties is essentially validating all the properties from an object, and if one of the properties is I-enumerable, I again call the collections are deeply equal method, and if the properties are deep, and then I check whether the properties are deeply equal, again with that method. How I compare the properties, it's a bit funny, but I use the root value dictionary from the ASP.NET Core framework, because the root value dictionary already caches a lot of response models the user returns. So if the user returns such response models, the root value dictionaries cache them with the property helper technique I showed you in one of my previous videos. So instead of caching my own types and my own properties, I decided to reuse the controller cache, because the controller cache will cache the values even if I don't cache them. So essentially I decided to use these dictionaries to optimize this essentially heavy algorithm. So I use the dictionaries and they provide me a key value pair, the name of the property, and the is the key, and the value is essentially the object corresponding to that key. So essentially I'm building string to object dictionary which contains the name of the property and the value of the property, and I'm doing it as fast as possible by using root value dictionary here. Okay, then I validate all the properties. If one of the properties is I-enumerable, I compare it with the collections method we saw earlier, and if the property is not collection, I use the are not deeply equal, which we already saw it. And this is the whole algorithm. it does quite a lot of stuff and it checks a lot of things, but it's working correctly. And I tried it to be as optimized as possible. So essentially tests should be quite fast. And that's pretty much the whole algorithm. So let's debug. Let's run one test in debug just to see how it works. So I'm going to debug the test we already saw. But before we debug it, I would like to thank my sponsors. As you may already know, these frameworks are written in my free time, so I'm open for all kinds of sponsorships, and some companies already did that. I have Softuni, Smart IT, Noble Hair, and 1Bit Software as my sponsors. You may check their websites. Very cool companies. I'm completely thankful for their contributions to my projects. And if you are looking for a job, for example, or if you want to see what the companies are doing, what kind of solutions they're providing, make sure you check them out. Thank you. And I have a special sponsor, which is Bellatrix Test Automation Framework, which is essentially the same tool I'm building, but for QAs. My tools are for developers. I am providing easy unit integration tests, acceptance tests, and so on, which are done from the developer. And these guys here are creating the same thing, a .NET framework which tests, but for QAs. And it has great APIs for UI testing and quite a lot of stuff actually. You may check them out if you're interested in UI tests and if you're a quality assurance engineer. Thank you guys, you truly rock. And if you're individual, you may support my channel or my projects by becoming a sponsor or backer on Patreon or Open Collective. Some people already did that. I'm extremely thankful and I would be very happy if you decide to join. Cool. So let's return to the code and debug the algorithm before we start implementing the reporting logic. So essentially I receive an anonymous type here and anonymous type here, and I need to validate whether it's both of them have the same values in their properties and in their nested properties. So first, they are not null, of course. I check the type. I haven't processed these values, so I'm going to add them to the weak conditional table, which essentially saves my objects and allows me to check them if they repeat again. Then I check whether these are objects directly. By objects I mean objects like this, because that's a special case, so I need to cover it. Then I check whether it's a collection. It's not. Whether the object is an anonymous type, it's anonymous type. So I check the other one whether it's anonymous type too, and again it is. So both of these are anonymous types, so I can compare them. Then I check them whether they're assignable from each other. For example, if I have a cat and an animal, or an enumerable and unenumerable, they are not. Then I check whether they are primitive, they are not. Whether they have an equals operator overridden, by default anonymous type don't have that. Then I check, I don't do that check. I need to check whether if the types are different, and currently they are, because I have two different anonymous types. And because they have an overridden equals method, I don't want to use it. So that's why I skip that check for anonymous types, because the equals method will not work for my case. Then they are not comparables, and what I need to do is to check the properties. So I create two dictionaries from the properties. I have ID text and nested, which is essentially what I'm doing here. And I have the ID text and nested from the actual object. So one by one, I validate whether these two ones are essentially the same. So I call the same method to validate whether 1 and 1 are equal, because I don't know that they're that primitive and easy to check. So all these checks are fine. Ones are not anonymous. It's primitive, so what I do is just call to string, which is essentially one a string and one a string, and I return true. Everything is fine. So the properties are not different. Then if I continue this way, I'm going to validate the other properties, which are test and test. I'm not going to do that because it's the same. And I entered so I invoke the equality of the string operator here. That's important. So properties are not different. And the last one is a nested property. So it has a nested object. So when I call that method, I'm comparing to object which has a property is true, and the process repeats itself. So I haven't met that object, so I save it in my weak table. Then I again validate whether it's anonymous type, whether it's a collection, and so on. That's the algorithm, and it's quite tested. It works very well. I believe it works with all kinds of objects and situations, but maybe there is something missing. If somebody reports a problem, I will fix it. But for now, that's the algorithm. So what we want to do now is we want to change these true and false to return an object with report. What's the actual problem, and which property failed. That's the idea here. So I'm going to continue these. Yeah, I'm going to continue with the implementation in my next video. So thank you for being with me, and I hope you learned how to compare deeply to objects, because I spent quite a lot of time, I believe 3 to 4 days, implementing this algorithm back in the day. It was like in 2016. And it took me quite a while to make all the tests pass and all the different kind of situations here. So see you in the next video, guys, in which I'm going to start developing.